Hello, everybody. Welcome. Thank you for joining us today. I'm very excited to welcome you all to our live webinar from Cardinal Health, and they're going to talk about how they accelerate their cloud migration and lowered observability monitoring costs using AIOps. So we have a great panel, great session, lots of information, and feel free to use the panel to ask any questions as you kind of learn about the information from Albert and Archer. And let me use this opportunity to present them to you so you can kind of understand who the speakers are and what kind of background they bring to today's presentation. So first, I'm going to introduce Chris Archer. He goes by Archer, and Chris is okay, but never call him Christopher, and you'll be best friends. He's been at Cardinal Health for 14 years. He started as a password reset analyst at the help desk and has moved his way up to now leading a team of 70 incredible engineers covering cloud platforms, discovery services, observability, ServiceNow, and enterprise IT ops processes. Joining him is Albert Wong. He's been at Cardinal Health for about over 9 years, but he also has 26 years in IT, working with different types of monitoring, observability, event management platforms, and he's based out of Burlingame, California. So two of our panelists have probably all the experiences that you're going through in your own organization, working with similar tools, challenges, and processes. So I think today's presentation will be very relatable to you as you kind of understand and think about your cloud acceleration process. And with that, I will hand it over to Archer.
Thanks, Adam. When you talk about Cardinal Health, we are a Fortune 14, $205 billion company. Our stock is about 104-ish, 105-ish, someplace in there right now. We are headquartered in Dublin, Ohio. The big thing I call out is we're an organization that grew through acquisition. And so when I say that, hey, we run almost every tech stack imaginable, it's probably someplace in our environment. It's because we have grown through acquisition, bring in new stuff, et cetera. And so it's a mighty challenge for us on the observability side and on the cloud side to kind of manage all that different technology. Cardinal Health, if you're not familiar, is a pharmaceutical distribution company. We service 90% of the hospitals in the United States, 10,000 specialty physician offices. We're in 3.4 million patients at home. Pretty much, if you're in a hospital, you're in a pharmacy, in some way, there's a Cardinal Health product sitting on your shelves. Where that matters for us in the observability space is that when we have an outage, people's lives are impacted, and it's not something we take lightly. So when you can't get an order through our system, there's a patient on the other end that might be needing a life-saving drug, and that's why we take kind of reducing outages and reducing length of outages so seriously, because it is an impact. We are essential to care, and there is impact on patient lives when we aren't operating the way we need to. When you look at our cloud organization, we started back in 2014 with our first server kind of in AWS space. In 2018, we started this effort around GCP and this cloud migration, and that was driven out of a data center exit. So Cardinal Health went from an organization that was running 100% on self-run data centers to where now we run 80% of our workloads are in public cloud. We sit in mainly GCP, AWS, and Azure. We have 12% of that's running in private cloud on VMware, and then we have about 8% left on-prem, either inside our Dublin office here or at a colo location. So from a cloud migration standpoint, we've done all the big work and kind of moved all those workloads into the cloud, and are a cloud-first organization going forward. But when we came out of that, when we finished that migration, what we were seeing was an increased noise to signal ratio. We were actually going in and reducing our observability, going in and setting our thresholds higher, saying, hey, don't alert me until this processor hits 98%, when before it used to be 90%, just to reduce the noise in the environment. And so it was an anti-pattern. We were kind of moving the wrong direction for what we want to see, which is notify earlier, notify quicker, so that we can make an impact to it. We're also seeing an increased cost. Our monitoring platform overall was increasing year over year, but at the same time, our outages and our mean time to resolve was also increasing. And so you kind of saw a pattern that we didn't like. We were spending more than ever, but we weren't getting the ancillary benefit. And then finally, because of that nature of, hey, we have a large sprawling environment with a lot of different technology in it, we have a lot of monitoring tools, or had a lot of monitoring tools. We needed something to bring that all together in a single vision, because what was happening is you'd be troubleshooting an item and you'd hit a brick wall and have to go to the next team or go to the next tool to figure out what's happening and figure out the solution to that problem. And so we needed a different approach. And we found that AIOps, connecting our observability data with our ITSM, our action side, driving in automation, that that you see here, kind of that key slide from Gartner, and driving toward AIOps was what we really needed to do. We kind of needed to push reset and take a different approach going forward to make sure we're driving the right value for our organization. And so in 2022, we started an AIOps restack project. We replaced our event correlation tool, bringing in BigPanda. We replaced our APM observability tool from an old tool, now utilizing Dynatrace. At the same time, we changed where we were running our kind of logging layer. Full restack of our monitoring capabilities and kind of rallying around that single kind of ecosystem going forward. Our goal there was to reduce and eliminate the number and length of outages. It's a direct tie to sales and customer satisfaction. I talked at the beginning here that, hey, we have patients on the other end, and that's incredibly important to us in our culture. We want to make sure our patients get the life-saving drugs when they need it. But there's also a bottom line hit. We were able to show that every time there was an outage, we saw less dollars in our pocket from a revenue perspective. And that was the main thing we were trying to fix, is both be up for our customers, but also protect our bottom line and reduce the risk in the organization. The second item was unlocking resources and reducing alert noise. We kind of did the math and figured out that there were a lot of folks spending a lot of time closing alerts that weren't driving action, false alerts or alerts that just didn't really matter. We were spending a lot of amount of time just closing those tickets and managing noise in the environment rather than managing the things that actually drive that uptime and drive the mean time to resolve. And then the third item was we wanted to reduce the overall cost of monitoring observability. I started this saying, hey, we saw an increased cost. We didn't want to spend that much, and we felt like we could spend less and get a better outcome. And those three goals were the things that we kind of rallied around around the AIOps Restack project. Started in 2022. We completed most of it kind of 5-6 months later. We finished up the last part of it here in November this past year. And so how's it been going? So in 2 years in, when you look at our success so far, in 2023, we generated 3.1 million alerts from 31 different data sources. But instead of generating 3.1 incidents, we only generated 409,000 incidents. So 87% overall compression. That's where we're freeing up our resources, making sure they're focused on the things that actually drive value, but also just reducing that noise in the environment so that we don't spend time chasing an alert that might not actually be impactful to our organization. 1 in 6 alerts have a suspected root cause change. So we have a 56% correlation overall. That's the main driver where we're really focused to drive that number up higher. But what this means is when you do get an alert ticket, 1 out of 6 is telling you what we think the problem is right there. Lets you quickly fix it, quickly go in after it. The other item that I think I'm proud of is the 106 users active in the platform. When we first started out, it was really focused on our enterprise monitoring team that was really in the platform. Today, we've reached across to those application teams and helped them get into the platform and really using it. And so 106 users doesn't sound like a lot. It actually is significant considering when we started, it was at like 4 or 5. I think the big story here is our number of SRTs. An SRT is our incident response. Hey, when something goes bump in the night, production isn't working. You can see in the graph, we have seen probably about a 5, maybe 10% decline in the number of outages that happen in our organization. And then bigger than that is about a 36% decrease in the length of those outages. So when stuff does break, we're fixing it faster. We're getting that getting the system back up and running quicker, and helping make sure our business is doing what it needs to be doing. And with that, I will pass it to Albert here to kind of cover some of our key learnings and things that we learned along the way.
Thanks, Arthur. So we're 2 years into it, and some of the key learnings that we found is that really we wanted to make sure that we added the APM ID or equivalent identifier for every alert that were tagged at the source, preferably from the platform itself. We rely on enricher maps to add a lot of context to every alert. This helps in terms of when we're dealing with SRTs or we're dealing with major outages. There's a little bit more information that provides a lot more context than just simply a raw alert payload. We make sure that BigPanda is part of the change management and problem management process because we want to make sure that we continually have a feedback loop. You know, did an outage, did we have a monitoring alert? Yes or no? Was there a change involved in that caused that disruption? Did BigPanda surface it? So we want to make sure that we're continually working with our teams to ensure that there is a feedback loop and we can address any gaps as quickly as possible. And finally, the leveraging unified analytics. It's been a little bit of a new capability. Originally, it was just dashboards, and then they released unified analytics. So we're leveraging that to really combine both the data that we currently have in BigPanda as well as our ServiceNow data to help us provide a lot more insight into alerts that either are noisy or ineffective or even redundant. So those are a lot of the key findings that we found in the 2 years of operation so far with the migration. So one of the first things we want to mention is that really alert enrichment is your starting point. It's the basic foundation. You know, we deal with 31 different alert sources. Some are with the BigPanda out-of-the-box integrations. Some are APIs, some are emails, and some are SNMP traps. So we know that from an alert payload perspective, they all kind of come in various shapes and sizes, and not all data points are the same. So that's really where the alert enrichment tags help normalize your payloads. So for us, we've kind of went with the strategy of utilizing a naming standard for our enrichment tags, and we tried to standardize on the set number of tags that are leveraged throughout our entire processing, right? So an example is like for any of the normalized tags for our payloads, we will use BP underscore and then, you know, a representative name. For anything that we're pulling data from a CMDB CI record, we use an enrichment tag with the naming convention of CI underscore. This way, when you're looking at alert payload in BigPanda, it can have a lot of data points. So you can just key in on the BP underscores and the CI underscores, and those are the key pieces of data that kind of help drive a lot of the context and a lot of the automation that we're doing today. And then enriching alerts using external data sources. Again, it's adding more value. So we're passing an APM ID number in the alert. How many people know that APM ID 1234 is for WebSphere or something, right? We don't have that. So by being able to leverage external enrichment through the CMDB to provide some more details about the application, maybe the ownership lineage in case we need to escalate it up, and what business context is there? Is this customer impacting? Is this on the pharmaceutical side of the business? Is it on the medical side of the business? And finally, we also use the traditional CSV files or the enrichment map tables to kind of fill in data gaps where platform level tagging isn't possible, right? So there are certain alert sources that we can have full control of the data that's being sent, which we would require like an APM ID value to be provided. But for those alerts where we don't have a lot of control, like SNMP traps, for instance, this is a perfect example of being able to use a CSV file to provide that additional enrichment to fill in that gap so that we can holistically have the same type of enrichment happening for all alerts that are being processed. So this is an example of how we're enriching some of the alerts with our ServiceNow CMDB and the CSV data, right? Just a screenshot just to show that, hey, you know, we're grabbing a bunch of data from the CMDB, or we're also utilizing a CSV file, and we're populating some of these BP underscore alert tags with those values. And here in this black screenshot here is showing the alert enrichment coming from our CMDB. So ultimately what that ends up with is that we want to make sure that every alert has a BPM APM ID number. And then with this APM ID number, it performs a lookup to then enrich all of this other data. So now I don't need to worry about memorizing what APM 0030243 is. Directly in the alert, I can see that the application is the SAP basis for medical. There's a description of the actual application. I can see that it's on the medical business segment. It's a hospital supply business area. And I can also see that it's directly customer impacting, right? So now I know that this is a highly critical alert because of all this other context that's provided by the enrichment that normally would not be there if we were just dealing with the simple raw alert. And the other thing about this is that we want to make sure that we're continually feeding BigPanda with change data. So we are a ServiceNow customer, so we're leveraging the ServiceNow change module. So obviously we're sending the change data from ServiceNow to BigPanda to kind of surface as part of the RCC action. But we're also starting to account for other non-traditional change actions, such as audit logs, GCP cloud functions, AWS Lambda functions, as well as deployment scripts. because we realize that in the environment that, you know, we're using Jenkins, or we're using other CI/CD pipelines, or we're using Dynatrace to monitor these things. There's changes that are happening in the environment that aren't always covered by your traditional change record in ServiceNow. So by also integrating some of these other change data sources, we're hoping to get and improve a much better RCC correlation as we process more and more alerts here. So, you know, for us, it's making sure we're reviewing our change processes. We want to make sure that we're aligning the data points, because with root cause correlation, we're relying on the AI and BigPanda to do the text pattern matching, right? So it's really important that your changes are described properly, are tagged with host properly, and with enough data points that hopefully we can have a successful match when it comes to a monitoring alert that we process, and that RCC can surface a suspected change that meets some of these data requirements. And again, as I said before, we want to make sure we have a continuous feedback loop to improve RCC, get the number of hits of RCC to go up, you know, every year, every month, every day. And then, you know, moving on, Unified Analytics really, when it was introduced, I wasn't exactly sure what the benefit would be, right? Because we had dashboards and things like that. But after spending time and working with our, you know, customer success team, it really has been a great way to really dive deep into our monitoring alert patterns. And one of the key ways that we're able to do that is we want to identify what some of the key alert tags would be useful for Unified Analytics. And the reason I say that is not every tag in your alert is available for use in Unified Analytics. So you basically have to engage BigPanda support, and you just got to get these tags whitelisted so that Unified Analytics can be used for those as filtering, right? So we can create numerous Unified Analytics dashboards to surface the trends, identify those noisy neighbors, and measure a bunch of KPIs such as MTTX. And obviously, out of the box, there are some UA dashboards that are a pretty good starting point, but we've also had the pleasure of working with our customer success team to create some really custom targeted dashboards for some of our use cases. And again, it's a very iterative process. When we first started with Unified Analytics, we had a certain set of, you know, BP underscore tags. Then we realized that, you know what, it'd be helpful if we added these additional tags, or it'd be helpful if we added these other tags. And it just kept evolving until finally we got to a really good point where we had enough data points and enough filters to really drive a lot of the analytics that we're looking to achieve from the data. So I think at this point, I'm going to end the presentation and just kind of move over to a demo of some of our UA dashboards. Give me one moment. Okay, can everyone see my screen? I think so. Okay, so here's one of our UA dashboards. It's basically giving us an overview and context about the alerts that are happening here. So we see in the last 90 days, we've deduplicated about 230,000 alerts. We've had, you know, 118 total incidents, and we've had 98,000 that we actually created incidents in ServiceNow. Out of those alerts, we're obviously looking at how many incidents do have an APM, you know, how many don't have an APM, right? And these are some of those dashboards that kind of help provide some of that insight, and it gives us, even from a leadership perspective, who our directors have the most alerts within the alert stream that are sending APM IDs. And then finally, we can look further and say, okay, well, how many alerts aren't sending APM IDs? You know, where can we start to work with these teams to either have them tag their alerts at the platform level, or do we need to start generating and creating more enrichment maps to kind of fill in the blanks here? And I'll want to be, you know, honest here. The reason why there are a lot with APM IDs is that, you know, we still have alerts that are sending to our old platform. And they're not part of our new standard payload. And our new standard payload with BigPanda obviously requires APM ID. So we're kind of in the process of completing the migration. So we're going to see a lot of these numbers come down to hopefully close to zero, so that every alert that BigPanda processes will always have an APM ID, right? And again, some of these will kind of show us that, hey, 71% of the alert volume is coming from this one, business area that doesn't have an APM ID. And you can kind of start to dive into alert counts. You can see what teams are involved. You can start to see like what hosts are involved, et cetera. And then you can kind of start to see some trends over time with a lot of that behavior with no APM IDs. And then we also have a view on what are alerts that we're not actually creating incidents in ServiceNow. What's the purpose of it coming into BigPanda if we're not going to send it and create an incident ticket for a team to be actionable in ServiceNow. Sometimes there's a good business reason. Our network operations center, they tend to be the first line triage for a lot of network alerts. So they don't want incident tickets created because they would like to triage the alert in BigPanda. And then if they're unsuccessful in resolving the issue, that's when they want to actually create the incident ticket in ServiceNow. And they can do so directly in BigPanda by clicking the share button, the auto share button, which is a great feature for them. And then when we scroll down further, we can also see that, here are a lot of the compression improvements on a per director basis. So we can kind of see like how much compression we're getting out of the alert stream that we're receiving from some of our business areas here. So some of the other dashboards that we rely on is the alert correlation patterns, right? In terms of what's our trend in terms of total number of alerts, how many are being duplicated, what's our overall correlation percentage here. And again, we can see the trends in here. We can also start to look at sources to see who is actually correlating best and who is not correlating best. And what we can now do with this information is we can go back and analyze the alerts, work with that team to understand the nature of the alerts and why their correlations are so low. Is there a business reason why we can't get a higher correlation, or is it simply that maybe their alerting is instrumented incorrectly? So this gives us a chance to help identify a lot of those use cases and start being partners with our teams and working through them. Because I think one of the biggest things at Cardinal is that the culture has been mostly working out of ServiceNow incident tickets. So even with our previous event management platform, our applications teams never logged into that platform. They only cared about closing tickets, receiving tickets, and closing tickets. Now that we're on the BigPanda platform, and now that we're able to show a lot of things and benefits like the root cause, we're starting to get more engagement with the application teams so that they can start looking in BigPanda to kind of surface and understand these types of details and understand more about their alert stream. And hopefully we can make improvements that will reduce the volume, reduce the number of incident tickets that are created, but at least create more high quality alerts and high quality incidents that are actionable for everyone involved. And again, some more stats about, the top 10 of assignment groups with the highest alert count, but the lowest compression. So here's a perfect example is this team is generating 200,000 alerts and we're actually creating 6,000 incident tickets. So their correlation is really like the really low compression here. So now we can focus on these top 10 teams and really start to dig in with them and figure out why they're generating this many alerts in a short period of time. Then we can also look at actual alert sources. We can see if there's a specific alert source as well that's outside of a team, but maybe there's a specific alert source that is generating a lot of noise potentially. And then, we look at Netcool. So yeah, Netcool was our previous event management platform. So we still have a lot of alerts that are going to that platform that are just forwarded over to BigPanda for its processing. But, we can look at, something like the MFT where they're creating 14,000, 9,000 alerts, but their compression is very low. So now we can, again, start to target some of these sources some of these teams and really try to drive some of the improvement for them. And then, this again is a further look at the compression and the trending over time. What are our top alerting hosts? What are our top alerting applications? Okay. And then what are our top alerts itself? The interesting ones would be, the top recurring ones. So there's the CPU unit limit utilization for this one particular project, and it's generating 51,000 just within the last 30 days, right? We need to look into that. Is their threshold set too low? Is the nature of their application just extremely volatile and spiky from a utilization perspective? What can we do to help them tune this down? Because ultimately, this does lead to a lot of incident tickets that are being created that are probably just not actionable for them. And the more we can drive down, reducing the noise, reducing these unnecessary incidents, the less dollars it's going to take for manpower to kind of close all these incidents out for us. And then finally, we can kind of look at more of all right, what alerts aren't giving us an APM ID that we aren't able to enrich with a lot of that data? And now we can start to look at these alerts and see, okay, can we work with these teams? Can we get them to update in the platform, tagging with APM IDs? Do we need to create the enrichment maps to fill in the gap for these? And really, again, not to be the dead horse, but we're really looking to drive that feedback loop. We're looking to really improve and reduce the overall usage and consumption of incidents, because it really just takes up a lot of man hours for things that, when you look at an incident ticket and the closure code consistently says no fault found. Well, why is there no fault found? Obviously, an alert got triggered for a reason. An incident ticket got created, and for you to say that there was no fault found, we need to figure out why you consider it no fault found. Is it an issue on the monitoring side and alerting side? Do we need to eliminate this alert? Do we need to tweak the threshold? What can we do to help drive it? And I think that's one of the biggest things about this transition over to AIOps is that we also are trying to bring in some culture change to the environment, because we're very ticket focused, but we need to do more about root cause problem solving versus incident ticket closing. So with that, that's it for my portion. So I'll just hand it over to Adam.
Yeah, great. That was awesome. Thank you, Archer. Thank you, Albert. That was really insightful. A lot of great lessons learned. Members of the audience, feel free to use the question forum to ask any questions. We are live, so we're happy to answer them for you now. While we wait for them to come in, maybe I can start off the Q&A session for me, both of you, or one of you can take it. When you're presenting the concept of alert payload standardization, maybe application teams haven't heard of this concept before. What kind of resonates to them when you present this idea that they need to change some of the monitoring is being set up, or what data they're sending, and what the impacts will be of these teams to drive adoption?
Yeah, so I think in the past, we had a very tightly defined alert payload. But what that also meant was that the system wasn't open to users to make changes. So anytime a team needed to change an assignment group or a priority for an incident ticket, our team would have to get engaged and we have to make the coding changes for them. By moving over to BigPanda and having the standardized alert payload, we empower our application teams from a self-service perspective to own that. So now if they are able or they require a change in incident ticket priority, require a change of routing, or onboard a new system to generate the different set of alerts, they have the power to do that on their own, and it reduces us being that choke point so they can move a little bit faster on their end.
I think another thing, Adam, is we just show them kind of what an alert inside of BigPanda that's not been enriched, that doesn't have that APM ID, what does that look like, and what is one that has it with it, and what does that look like on the ticket side? And so when they get a ticket that's gone through enrichment and has an APM ID and has all this data in, they have all the information there at their fingertips. And so just showing kind of app teams the value of, like, why is enrichment important? Why having an APM ID to alert? What does it do for you on the other side? They generally nod their heads and go, okay, that makes sense. Now, how do we go about doing that? And so it's not hasn't been a hard sale. It's more been a prioritization problem of they have a lot of work going on. When do they get to that? And so we fight prioritization more than convincing them it's the right thing to do.
Gotcha. And so once you're able to actually work with these teams and you show the power of enrichment, and you see how correlations improving, what are some of the metrics that you're sharing with executives or higher ups in terms of the impact to operations teams from doing that?
Yeah, so I think there's a couple that we look at on a regular basis. So I showed earlier the graph of the number of outages, the mean time to resolve. Those are key ones because
Hmm.
that's our top line. We want to show that we're protecting the business and reducing risk in the organization. We also do we're a managed service organization. So the number of tickets that are going into our queues matters. And so we have a lot of reporting just simply about the number of tickets that are going in. How many are we generating? How many are being worked? There's also a metric we kind of look at about how many are being auto closed. So if we're
Hmm.
generating 1,000 tickets, but 999 of them are going in and we're mass closing them, those tickets aren't valuable. They're just noise on the line and they're just padding numbers elsewhere. So we're not in a pay for ticket type culture, but there is a lot of focus on like how many tickets are we creating, how much noise we're making, and that's one of the key metrics we look at, Adam.
Okay, great. There's a question around AI. We hear a lot about it in our day-to-day lives. We're all very excited about it. Where do you think AI will help in your operations teams and where you're working with different groups? There's a lot of things that people think what it can do, but I'm curious to see what your expectations and where you think you would like to apply it.
Albert's not jumping in, so I'll jump in. I think for the machine learning base, you have a bunch of data. I use the term a lot, like, hey, the amount of data that we need to process is exceeding human scale. Using kind of the machine learning based AI, I think, is an absolute win to sift through that data, make sure we're creating an actual insights and driving forward. That's all what AIOps is about. I think, Adam, your question was about Gen AI and kind of how we could utilize
Mhm.
Gen AI in our organization. I think, again, for us, we're looking at where we can apply it to just amplify the actions of our team. So instead of taking 10 minutes to write an email, how do I take the data that have here to kind of create a root cause analysis or what it is immediately and not taking the time to do that? How can I use it to surface
Mhm.
insights that we might not see when we look at it? Those would be a couple things I'd call out.
Okay, cool.
Yeah,
Um,
at least in terms of BigPanda, right? Obviously, we're leveraging the AI for the correlation patterns, right? We're leveraging the AI for the root cause correlation. So those are two of the big components that we're relying on. And I know we've been doing a demo, a POC of the generative AI. So it's
mhm.
basically allowing um, uh, correlated alerts to have a generative AI uh, react on that alert and provide some more human context, human readable explanations of what the scenario is happening and potential root cause as well in a very plain, easy to read methodology versus having to look at alert tags and trying to figure things out.
Mhm. Yeah, good. Thanks. Last question, then we'll wrap it up. Um, you guys set a great foundation of best practices, how to get started working with observability teams, operations teams. You shared a lot of great insights into how to using data and analytics to kind of indicate further progress. Where are you going next? If you were to talk to a customer who's maybe on this journey and they're curious to know what's the next step or where the next level of benefits will arrive, where does that come from? Where does that go?
I think for us, we still have that vision on the thing of how can we get to auto remediation, self healing type concepts. We're not there yet. We don't have the confidence yet. We have some things that actually, based on the ServiceNow ticket, go in and intervene in our environment. But like, how do we do basic health cleansing? I was actually talking to someone yesterday around the idea of if every time we get on the outage, the first thing we do is a rolling restart of the servers, and that fixes 90% of our issues. Let's just automate that. Let's just have the alert generated from BigPanda and go, hey, we need a rolling restart because it's safe to do. It doesn't impact our customers. It's something that we go and talk about and spend 30 minutes before we pull that trigger. But we know rebootion is the solution in a lot of cases of restarting those environments. So how can
Mhm.
we get to automating some of those kind of self-healing items? I think is probably the next thing that we'll focus on in our fiscal year 25 that starts in July.
Cool. Great. Albert, we have one more question. If you have a second, it's related to you. Um, well, audience member had a question around application metadata in the CMDB. So does AIOps have both the application metadata in the CMDB and also the network topology network view? to understand upstream and downstream impact of the application. How was that information gathered? Is it from the app teams, discovery, other facets?
Yeah, so I think for us, with the way that the enrichment is pulling in, it's not pulling in topology information. So what we're currently working on is we're looking at Dynatrace. That's our primary monitoring platform, and Dynatrace provides a lot of topology data in there. So what we're actually looking at fairly soon is how do we get that same topology information shared across over to BigPanda to provide that view of upstream and downstream. So that is another portion. We haven't implemented yet, but it's something we are starting to look at least from the enrichment perspective. It's really just, when we get on an outage and we see a monitoring alert, we want to make sure that there's enough data for folks to quickly be able to make decisions without having to figure it out. And that's kind of the nice part of, of being able to enrich it, is because it's there, right? Kind of when I showed before, it's like, I don't need to remember APM ID number and what it's doing and whether or not it's customer impacting or whether it's pharma, medical, or corporate. But also in that line, we're able to then, instead of having to log into ServiceNow and try and search for changes, and we know how cumbersome and slow ServiceNow can be when we try to, search for something, hunt for something. Easily in the BigPanda change tab, I can just put a couple of keywords in there. If no changes got surfaced by RCC, I can still search, broad-based text search, and I can still provide a list of changes that meet my keyword searches. So it's still a tool that kind of helps us speed up that kind of like root cause type of identification. So, I think, hopefully that answers the question, but, I think we're all trying to get there, right? That single point of glass, let's figure out what the blast radius is of this alert, right? And that's definitely the next step for us.
Okay.
Yep. And Adam, I'll add in just on the CMDB side, we're actively going after improving our CMDB, making our CMDB better. The question mentions kind of how does that data get in, app teams, discovery, et cetera. We do all of that. So we have discovery jobs that are going out there to identify our organization, both on the server side and the network side, that gets fed into CMDB and gets kind of put in there. We have app teams going in and updating it as well. We have service graph connectors to pull all that data into the CMDB as well. And so we're trying to really rally around, make sure all the connections, hey, this app relies on these 30 things to understand what's part of it. So then we can start saying, hey, one of this thing down, how many apps rely on that? That's an active work stream. I don't think anyone raises their hand and says, hey, I have a great CMDB. I have not met a single person across the industry that's willing to make that statement. I think ours are better. Ours is getting better. I think ours is improving as we spend a lot of time investing kind of in that discovery, in connecting more data in, including BigPanda itself. BigPanda itself is a feedback loop into our CMDB process. So when it finds something that's not showing there, some of those dashboards that Albert shows, we take and go, hey, why is our source data not as good as it needs to be? And we use that as a feedback loop into that organization as well.
Okay, awesome. All right, Albert, Archer, thank you both so very much for taking the time to present today to the AIOps community. We learned a lot. There's a lot of great best practice this year. I think it's very valuable for anybody in their AIOps journey to understand what you've done and to build upon that. So thanks again. And for everybody in the audience, this will be recorded so you can watch it on demand again. And if there's any questions or if you want to connect with Albert and Archer on LinkedIn, I'm sure they'll be happy to connect with you.
Thank you.
Okay. Thank you, everybody.
Yeah, thank you. Take care.